box and whisker plots are another way to display data, so let's throw some data down here. Write down these numbers: 10, 11, 15, 10, 9, 14, 12, 8, 9, 15, 7, 10, 10, 14, 18, 19. Oops. 18, 19. This, by the way, according to the book, is the data for 16 students' oldest sibling. Oldest sibling. So I should have just asked you guys. It would have been just the same. It would have been more fun.
Yeah, let's
You
do
could have told
that.
me that your siblings or whatever.
And the next one,
Mine is almost.
Oh, that's your assignment. We'll collect the data and I'll have you do a box and whisker plot of your oldest siblings. Huh?
Wait,
16 difference, for example, I would say Emma Kate, your oldest sibling is how old? 17, and then Steph, yours is 21, and then Katie, yours is 18, and then Jacob Wilman, yours is 34, and Kelly, yours is 18. So if in fact you have one there. Okay. What a box and whisker plot does, okay, it really separates data into 4 pieces. And those are called quartiles. Quartiles, which makes sense because quart is whatever we talk about for 4 or whatever. Now, the first thing you need to do, unfortunately, is arrange from least to greatest. Just like when you do measures of central tendency, you need to go from small to big. So we're going to have to redo these numbers again, and the smallest one is what? 7. 7, 8. Is there another 8? No. 2 9s. If I make a mistake, please point it out to me. How many 10s do we have? 4? 1, 2, 3, 4. 10, 10, 10. Any 11s?
Yeah.
1 11. Wait, how many, did I get enough 10s?
Yeah.
Yeah, 1 11. 1 12. No 13s. 14. 14. 2 15s.
They don't really have anyone.
18.
Just an 18 and a 19?
My sister's
18 and 19.
My sister's almost.
Give you a chance to do that.
Jacob is 30. How old's your
Okay.
dad? Is he?
Get rid of this. No.
Just exit out.
Uh-oh.
Yes. Well, middle is still young.
Uno momento, please.
How many forms? All of us have older. Most except for Jake. And
I am the youngest in my family.
Okay, step number 2, which I seem to have messed up here already. Step number 2 is go ahead and draw a number line for these things. Doesn't like it right there. Dead zone. Number line. Okay, so we are going to do this. It goes from 7 to 19. So you're going to draw your line. and mark it accordingly. We'll start at maybe 6, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Not a bad number line if I do say so myself. Get your number line down there. Okay. That leads us to step number 3, is find the median of the numbers there. And if you remember, the median is kind of how the middle. So if I've got these numbers, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. The middle of 16 is 1, 2, 3, 4, 5, 6, 7, 8. It's actually between number 8 and number 9. What happens when I need to find the median between number 8 and number 9? Find the average. What's the average of 10 and 11? 10 and a half. So this, ladies and gentlemen, right here at 10 and a half, you draw a straight up and down line, and this is your median. And what that tells you is that, okay, tells you that half of the numbers are smaller than that.
Oh.
Half of the numbers are bigger than that. Okay. It separates it into 2. But notice, I said we're separating things into quartiles, which means we're making them into 4 equal groups. So what you have to do for step number 4 is you need to find the medians of both halves. In other words, okay, I've split my data into this half and into that half. Now I'm going to find the median of each one of those halves, which there were 8 numbers in each half, so the median of that is going to be 1, 2, 3, 4 right here. Okay, which is what? The median of 9 and 10 is 9 and a half, which happens to fall right here. Correct? And the median of this one is 1, 2, 3, 4, between 14 and 15, which is 14 and a half. You with me on that? You need to find the average of those numbers. Okay, now, children and kids of all ages, you have just quartered the number line like this. And here's where the boxes come in. These make the boxes. This part from here to here makes a box. And this part from here to here makes the box, a box. Okay? The lines that you found, this line right here is called the first quartile. Okay? The second quartile is actually the median. We don't call that sector, we just call it the median. But this one here is the third quartile. This line right here. First quartile, third quartile. Now what do those boxes mean? Inside these boxes is the middle half of all the numbers. Okay? This is the middle half. Okay? The median from this side left was the first half, this was the second half, but the 2 boxes, this part right here represents the middle half of the numbers. Okay? And then the only thing we have left to show here is what we call the whiskers. It's called a box, those are the boxes, and whisker plot. Okay, the whiskers are just the, let me make sure I say it the way the book says it, the smallest number and the biggest number. The smallest value, you put a dot, and the largest, you put a dot. In other words, this. Okay.
Smallest number?
Smallest number I had was a 7. So here at 7, I put a dot and I draw a line. That's my whisker that shoots out. And my biggest value was 19, so I put a dot there and draw a line from there. That's my whisker that shoots out that other way. And this thing right here is what they call a box and whisker plot.
Wait, what do the whiskers mean?
They just tell you that it goes all the way down to here or all the way up to there. It can tell you a lot of things. Nothing good, I'm sure. See what else they ask you here. Oh, there's one.
Quick word class.
Well, unfortunately, there's one more long thing, and I'm not so sure I'm going to take time today to do it. Kylie, how?
Where's the second and fourth quartile?
The second quartile would be the median. We already called it. So you don't want that. The fourth quartile would actually end out there. So we don't. Those are not. Usually, when you're looking at data, this middle part really is more representative than the outside parts. Okay, generally speaking, because this is where most of the, we talk about averages and middles and numbers. Usually you look at the stuff in the middle because stuff on one side and stuff on the outside is kind of not as common. The middle numbers are. Steph?
What would we use these graphs?
I don't know. They'll ask you on tests. We'll get to that later, I hope. Now, just to do one more tomorrow, leave room on your thing because tomorrow we will talk about things that are called outliers. I don't want to, it takes a little time.
We know it.
I know, but there's a mathematical formula that you have to use to figure them out. Okay, outliers are simply numbers that would skew the data because they're so far away from the norm. For example, Jacob has a 30-some-odd-year-old brother or sister. Okay, that's just pretty much way out of the norm, but there's a formula that you have to use to see how far that is. So what I will do here, children, because we'll talk more about this tomorrow,